Greetings everybody, and welcome to our second video on dot products. In this problem, what we're given is that train tracks are running in a certain direction where they run 25 miles west for every 100 miles north. Then we have a group trying to catch the train that has a velocity vector of 10 miles per hour east and 30 miles per hour north. Their velocity enables them to just keep pace with the forward direction of the train. And so the question is, how fast is the train traveling along the tracks in miles per hour when rounded to 2 decimal places? So let's jump in and see how we can solve this problem. Now, in this problem, we're actually given a couple of different vectors. So the first vector actually being for the train itself. So let's see how we can write that down. Well, at least the track for how that is actually moving. We know that we are going 25 miles west, so our horizontal component is going to be a negative 25 for every vertical component of 100 miles that we move. Now we can factor that out, factor 25 out of that vector, and so we end up with also a direction vector of negative 1, 4, which just kind of makes our numbers easier to deal with. So the 25 really is just a scalar that's not necessary, just kind of makes the components a little bit bigger, and so we really don't need to worry about that much. So that really, for the most part, we can take the direction vector for a track just to be our negative 1, 4. Then also we have the velocity vector for the group that's trying to catch the train. And so for our velocity vector, we're told that that one will be a horizontal velocity of 10 miles per hour. And then we've got a vertical velocity of 30 miles per hour. And so if they are kind of keeping up with the train, kind of what we're looking for in this case is really just this kind of horizontal component of how much of our velocity vector is going to be in the direction of the track. And so what we're really wanting in this case is the component of our velocity vector in the direction of our track vector. And for that, what we then have is just going to be our track vector dotted with our velocity vector divided by the square root, and since we're in the direction of the track vector dotted with itself. So let's go ahead and make that computation and see what our velocity is going to be. So making our computation, the component in the direction of the track of our velocity vector v is going to be our dot product of negative 1, 4 dotted with our velocity vector 10, 30 divided by the square root of the velocity vector negative 1, 4 dotted with itself. And so what we have then for our numerator, negative 1 times 10, so we have a negative 10. 4 times 30 gives us a 120. Then in the denominator, we have the square root. Negative 1 times negative 1 is 1. 4 times 4 gives us 16. So really, we have 110 divided by the square root of 17. So if we plug that into the calculator, what we get for an approximation is 26.67891875. At least, and then our units were in miles per hour. So rounded to 2 decimal places, what we have is a train velocity, or a train speed, actually, of 26.68 miles per hour. So I hope you've enjoyed this example, and I will see you guys in the next video. Take care.